First of all, welcome to JFall, which is still the best one-day conference. Still, I saw a lot of conferences, but this is the queen of it. It's really great. Awesome. Yeah, welcome to the session Wargames, and it's not about the movie, and it's not about the other movie where you see the spy versus spy thing. It was really just me looking for something to make slides. So it's about Java vulnerabilities and why you should care. My name is Gerrit Grunwald. I'm working for Azul as a senior developer advocate. I'm also running a Java user group in Münster, which is not too far away, but it still took me 3 hours to get here this morning. So I'm a developer, right? So who's a software developer here in the room? As we learned, we are not software engineers, right? We are software developers. And I'm not a security expert at all. Do we have security experts here in the room? Then please leave. So on the 24th of November 2021, this happened. And I guess who was affected by this Log4Shell thing? Yeah, lots of you, right? Me too. And that made me think. Because I'm a little bit older, so in the 50s. And for me, the 20th century was where I started coding in 1982, and I'm from that area, right? From the era. So, and in this era, it was totally different. So we had a code that was self-written and closed source, right? So we had the source code was managed in a repository somewhere in the basement on the server. So our repository was 2 different folders, and we changed the names of the folders all the time. So everything was manually built, so there was nothing like a CI/CD thing. It was delivered on hardware like USB sticks, so CD-ROMs, even floppy disks. And it ran on closed networks or local servers. We had large monolithic systems, connected systems you only found in government banking and these kind of things. But the most important thing, we had the full control over the source code, right? There was nothing like we didn't use anything from anyone. We just wrote everything on our own. So the vulnerabilities have been totally different at these days because it was more or less password hacking, right? Or computer viruses, the first viruses that spread at that time. And it was the early days of internet hacking, but not really as we know it like now. So, and time flies. And after November 24th, I really found myself in the 21st century. And for me, security was before that. I write the code, I throw it over the wall, someone builds it and deploys it. I don't care, right? I will be honest with you. I never thought about security. And these days, a lot of open source software is used. So who's using open source here in production? See. And you just trust it, right? You just grab it from a repository. You just say, okay, dependency, Maven Central. Did you ever check if it's secure? Yeah? Good. Very good. So it's we have distributed source code management systems and automated build systems like CI/CD, hosted in artifact repositories. It's running on public networks. It's accessible via the browser or APIs. And everything is connected these days. And we don't have the full control over the source code anymore, right? We write some code mainly using other code. That's what we do. And we have a complete software supply chain these days. And that was different in the 20th century. And so also the vulnerabilities are different these days. And the most important or most dangerous thing is social engineering. Who is here on social media networks, whatever it is? Probably most of you, right? Did someone heard about SIM swapping? Because I saw there are security experts in the room, so you probably heard of it. And if you never heard of it, then look it up and then think about 2-factor authentication again, using your phone, because this is more or less taking over your phone, and that can take over your identity these days completely. So I was shocked when I read about it. So it's really interesting. We have lots of malware, ransomware, everything that is connected will be hacked. Spreading malicious code is way easier than before, and the whole software supply chain is under attack these days. And to give you an idea, because that was the reason for this session, when I stumbled upon all these issues with Log4Shell, all this stuff is happening in the US, right? I'm not native speaking English. So I saw all these acronyms and people just throwing them around, and I was like, what is it? I never heard of it, right? For example, CWE, common weakness enumeration. So this is a community-developed list of software and hardware weakness types. And you find them sometimes when there are CVEs. I will come to that. So if there are vulnerabilities, they have a CWE identifier. And then you can look it up here. I think the slides will be made available, but you will find there are a lot of QR codes and links, so because it's lots of stuff that you can look up and read through. So then there is the so-called NVD, National Vulnerability Database. So we have vulnerabilities. This is the place where we store them, right? We collect them in one place. This, not every country has its own. There's one big one, which is the NVD. And this is hosted by the US government, but it's available for everyone. They have an API. You can get an access to the API keys, for example, and then you can also query the NVD by yourself. And it follows the SCAP, the Security Content Automation Protocol. So everything's documented there, and you can look up stuff manually or even using an API or using tools. And in this NVD, we store so-called CVEs, Common Vulnerability and Exposure. So this is in principle a program, and it was made to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. That's the idea behind it. Sounds crazy, because if you see Log4Shell, then it's not saved as Log4Shell in the NVD. Of course not. It's saved at this one, CVE 2021, and then 44.22.8. So I think this is the running number, and that was the year where it happened. And when you look it up in the NVD, you find something like this. You don't have to read through it. It's more or less, it tells you the versions that are affected by this CVE. It tells you the vulnerability itself, so it explains to you what is the vulnerability of this CVE, and then it gives you some description. From which version to what version was it applicable, and all these kind of things. So, and you will find this for every CVE in the NVD. So it's quite interesting to read through that stuff, because it gives you an idea of what it really is, right? Because people throw around some rumors, oh, they can do this, they can do that. So just read it up. It's all documented in the NVD. And now we have the database and we have the CVE identifier. So we need a system to score them, because you need to know, is it low score, high score, is it critical, is it not critical? You don't know, right? So therefore there is a so-called CVSS, which is the Common Vulnerability Severity Score. And because it could be easy, but we make it more complex, we have not one, we have two. And this is the older one, it's the version 2.0. And there we only had 3 different levels, like low, medium, high. And that's the scoring on the right. And I'm not sure about the colors, because I just picked them. It's green from 0 to 3.9. And you will see with the next version, the 0 doesn't really make sense, right? If there's no vulnerability, why giving it a low? Doesn't make sense. And also 3 levels might not be enough. So this is CVSS 2.0, and then there was CVSS 3 and then 3.1. And we see now 0 is none, and we have also critical now. The problem is that the older CVs and the NVD usually only have the CVSS 2, where the newer ones have both, the 2.0 and the 3.1. So and they are a little bit different. So if it's not enough just to say the CVSS score is 5, you have to know which version. Is it the 2.0 or 3.1? And if we take a look at this Log4Shell thing, then this was the CVSS 2.0 is 9.3, and for CVSS 3.1 it's 10.0 critical. So this is the highest possible impact that you can have with a CVE, with a vulnerability, was Log4Shell. And to me, the whole thing happened because I saw it in Germany. We have something called the Tagesschau, which is the institutional news show on the TV every day. And in this show, they mentioned Log4Shell. And I was like, wow. Usually they talk about politics, but not like this stuff, right? And then when that happened, I was like, oh, that's serious. So I need to look it up. And that's where all the stuff started. So the question is Java secure? Did you ever ask yourself? You just download the updates and you guess it's secure, isn't it? Did someone check it? No, right? So there's a group. It's called OpenJDK Vulnerability Group. And this is some kind of an institution. So it's a private forum of trusted members of the community. And even if you're a security expert with some track records, it's not like, oh, I would like to participate. They choose you. You can't really apply for a role there, right? And they what they do is they review and receive reports about vulnerabilities. That means if you stumble upon a vulnerability, you can tell them, and I will tell you how to do that, and then they will review it for you, and then they will take action on that. For example, they will collaborate on fixing the issues. They don't actually fix the issues. That's done by other people, but these people coordinate the fixing. And they coordinate the releases of such fixes, right? And if you download an update for JDK, you will always find a list of CVEs that have been fixed. And this is done by this group, this list. Right? They maintain a list of CVEs patched for each release. That's what I mentioned already. And they do it by component. So we have a modular JDK. Right? By the way, who's running JDK 8 in production here? Okay, someone below 8, 7 or 6? Okay, and 11, 17, the Fearless, 21? Yes, cool. Yeah, so you will find in the modular JDK, which came from JDK 9 on, you will find different modules, and they track it per module, and that makes sense. And I will explain later on why that makes sense. So they discuss OpenJDK security-related issues, and they do not actively test the OpenJDK source code. That's not done by them. That's done by the vendors that create the OpenJDK distributions. There's also OpenJDK vulnerability advisories, right? And this comes 4 times a year with every update that we have in January, April, July, and October. And then you will get this describing severities, areas of vulnerabilities, and the affected versions. And it will look like this, for example. That is from October this year. So you can see that there have been 3 CVEs here. And you see the vectors, right? So this is the CVSS 3.1 score. And you see the components that have been affected. And as you can see, Corba in 8, but not in 11, 17, and 21, because that was removed from the JDK. So you can look up which JDK is affected by which CVE, right? And then also for OpenJFX, which is JavaFX, it's just the open source project of that. And there's way more information that you can look up. And it's quite interesting to read through that. So if you stumble upon a vulnerability in the JDK, and you might say, yeah, but it never happens, right? It happens a lot. And if you would like to report that, how do you do that? So you can write a mail to this email address, and it has to be encrypted, and you can get the key on the website to encrypt the mail. And you need a detailed description. You need the output of Java minus version to make sure that they know what version did you use. You need to write a proof of concept program to show the vulnerability and how it affects the JDK, a crash log, and some relevant environment information. So this mail you send to them, and then they evaluate if it's really a problem or not, and then it gets into this whole process of fixing the issues. And that leads me to the Java release cycle, because yeah, you might ask yourself why this is important for security. Well, it started like this, right? Who remembers Java 6? And it took forever to get Java 7. And I was so excited that I put the Java logo on my car just for the JDK 7 release back in the days. And it's still on there. So it's really, it was like, oh, finally we got the new version, 4.5 years. And then 3 years later we got JDK 8, which was huge. Why do I mention that? Because then it changed to this release cycle, right? Every 6 months now we get releases where we have short-term support versions. They only get 2 updates. They live only for 6 months. And then there is the next version. And then we have these black ones, which is the long-term support versions. Oracle claims officially there is no LTS release. But for these black ones, they give you longer support than 6 months. So it's long-term support, right? And every other vendor does the same. So this makes it, in the end, an LTS release. So you should stick to the LTS releases, first of all, in production. Except there's a really good reason not to. But the problem is, let's say you go to 12, because there was a feature, let's say JPackage was in 12. And you need that. So you deploy your version, JDK 12, 6 months later, that's it. No security patches anymore. So you have to switch to 13. 6 months later, you have to switch to 14, to 15, to 16. And then finally you get it in 17, and then you have long-term support. So it's really important to stick to long-term support versions, because then you can make sure that you get security patches for years and not for months. And that's really important. So how does that help with security, the new release cycle? Well, this is the old release cycle, and this is features per release. And you can see it was 56 in JDK 8, and JDK 9 had 91. That was because of the modularization with Project Jigsaw. And then the new version came out, and then you see the number of features in that releases dropped dramatically. And that means if you have less features per release, it's less potential vulnerabilities per release, right? Because new features add new attack vectors, maybe. You don't know. So that it helps having more releases. Who likes the new release cadence? Okay, it's not everyone, right? So, and it took me some time to adapt it, because I really was like, oh, really? We have been used to, oh, it's JDK 6 for now maybe 4 years, and then, oh, we have now JDK 7, that's fine. For another 3 years, now we have JDK 8, and then suddenly it's in 1 year, you step from 9, 10, 11, it goes, it's a different cadence. You have to get used to it. And it's also with the updates, right? Who knows CPU updates? Just a few. And I'm not really surprised. It's critical patch updates, and you can't get them for free. That's the reason why most of you don't know them. And how it works is CPU updates only fix vulnerabilities and critical issues. Nothing more. And then there is a so-called PSU update, patch set update. Does someone know that? Probably not, because this name is not very common. This is the updates that you download when you update your JDK and download something from a website. That's a PSU update. And this is all of them. Because like I said, CPU updates you can't download for free. What's the difference? The PSU is a superset of the CPU. So it contains the CPU, plus it also contains fixes for non-critical issues, and it adds new features. Small features, nothing like Loom or something. It's really small things where they say, oh yeah, that makes sense to add to the update. And why is that a problem? I will show you why that is a problem. Sometimes, not always. So to understand it better, we see the PSU update on the top and the CPU in the bottom. And you see the top contains the CPU, right? Plus additional features. That's in January, every year. And then we have in April the next one, and you see what happens. The PSU gets fixes and features where the CPU is based on the last PSU. That's how it works. So it takes the PSU 1702 and just adds fixes to it. That's it. That's the CPU. So that means feature-wise, it's always a little bit behind. And you might wonder why is this somehow reasonable? The reason is, if this PSU 1702 gets out in the wild, everybody downloads, you guys download and install it in production. You stumble upon problems, you report them, and then 3 months later we can fix it in the CPU. That's the reason. It's additional more time to fix issues in the latest PSU update. So that's why there is this CPU stuff, and then that goes on. It's always based on the last PSU, so feature-wise it's always a step behind the PSU updates, the CPU. And as I mentioned, this is not available for free, because that means additional work, and it's only available from a couple of companies. I think it's just Oracle, Bellsoft, and Azure who offers that. So keep in mind, updates are available 4 times a year. Who is always updating? Who's on the latest update for his version in production? Really? Not more. Okay, I have some interesting slides for you. Patch set updates contain CPU plus non-critical fixes and small features. And CPUs only contain the critical vulnerability fixes. And they're always a little bit behind. So the question is, why CPUs matter? Well, there's one example here, and we have a couple of them. With update 8U252, that's a normal PSU at that time. And it introduced a new feature. And this feature prevented Hadoop cluster and Solr from running. That means if you install that in production, suddenly Solr doesn't work anymore. And it was a regular update, right? If you use the CPU update, which you see the numbering, in the version 8 it was like this, the 251 didn't have this problem because it didn't have this little feature that they added. nobody thought that this might break Solr or Hadoop. And this was based on the former PSU here, right, on the 8U242, and they only fixed the critical stuff, and that's it. So this is things why CPU updates could make sense. I don't say it makes sense for everyone, but it makes sense for big companies. If you run mission-critical stuff or time-related things where you really are, let's say, high-speed trading, you don't want to have updating your JDK and then it stops working, right? So that's the reason for CPU updates. And now for all the people that don't update to the latest version, let me show you something, the impact if you don't update. So we start with JDK 17. It came out in September 21, and that was 17 GA. 1 month later is the update cycle. First update came out. 8 CVEs already fixed, just in this, right? That was 1701. Then the next one was in January, and you see additional 15 CVEs added. This is the stuff that have been fixed from 1701 to 1702. And this is different ones. It's not piling up here. And then again, and you see there also have been critical ones in 1703. And so on. I just count them all. But you see, in the meantime, we are at 1709. And you see it doesn't really stop. There's always CVEs, and CVEs means vulnerabilities in the OpenJDK source code. It doesn't mean you are affected. Not necessarily, because it could affect modules that you don't use. But in general, these are all in the OpenJDK code base. And that means if you don't update, you just stick to JDK 17 GA, then this is the numbers of CVEs that you have open. It's like open doors that can be hacked. And that means it's 55 different CVEs that are in your JDK if you don't update to the latest version. Think about that, right? And update your JDKs. Because people sometimes say, oh, well, if it ain't broke, don't fix it. Well, if it ain't broke, at least keep it up to date. It's not that hard, and you really should do that. It helps a lot, right? And another thing, and that's now an interesting one, modular runtime images. Who uses JLink? Oh, first of all, who knows what JLink is? Okay, interesting. JLink came with JDK 9, and it's a tool to create a tailored Java runtime environment for your application. That's the idea. So everybody that's using JDK 8 and below, you're out of the game. Everyone 11, 17, 21, think about it. Let me give you some ideas. If you reduce modules from the JDK that you use in production, then you remove the risk, or you reduce the risk of being vulnerable, right? And JLink makes this possible, and it came with the JPMS, with the Java Platform Module System in JDK 9, and it works like this. So you have a tool called JDEPS. It's also part of the JDK. So if you have Java home set correctly to, let's say, 11, you can type in JDEPS, and it will tell you what it is. And then you run that on your executable jar, for example, or your fat jar. It will analyze all the modules that you use from the JDK and will give you a list of modules. And then with this list, you can build your own runtime, your own JRE. Right? That's the idea. So you remove unused modules, and then it means you reduce the risk of vulnerabilities. And hackers cannot attack what isn't there, right? It's obvious. So your application doesn't need to be modular, by the way. So people always ask, oh, but I don't have a modular application. You don't need. This is about the JDK, right? To give you an idea, this is JDK 2101. That's all the modules that we have in there. And it's 69 modules, and the JDK is 339 megabytes. This is on my Mac. It's a little bit different on Linux and Windows, but it's in this area. Right? So that means who's deploying on the JDK here? You shouldn't do that, by the way. You really shouldn't. Because first of all, there's a JRE, which is the next one. You see it's not that many modules. And this is still 50 modules, but it's only 150 megabytes. Right? Well, it's smaller. That's okay. Still a lot. And then people complain that Java is so big, right? It's so big if I deploy it. Well, yeah, you take a base image, probably with the JDK inside, and then you add your whatever 1 megabyte application to it, and then you complain that Java is big. Well, if you use JLink, and I did that, this is for a push notification server that I've wrote, then suddenly this was only 11 modules, and that was only 48 megabytes. And you can even go further down to 30 megabytes for JRE. So really think about, and it doesn't really take that much to create a JRE in your CI/CD process. So if you compare it, you see the difference, and you get an idea. It's better to have 11 modules instead of having 69. When you only use 11, why having all the other stuff there, right? Okay, that leads me to the software supply chain, and you probably saw these diagrams or kind of diagrams quite often. It starts with us, developers. We get our stuff from a central repository, put it in our own repository, we build it in CI/CD systems, and then this also drags in dependencies from the central repository. Then we build containers, put stuff in artifact repositories. This can go back to the central repository, whatever it is, and also to production. This is usually, this is one kind of drawing the software supply chain these days. And it's not secure, first of all. And you can attack it in different ways. And for example, you can submit bad code. I don't go into detail because that would it would lead way too far. You can compromise the source control system, the build from modified sources, compromise the build platform itself is possible, and you can upload modified packages. If the artifact repository doesn't make sure that it's coming from a trusted CI/CD build system, you can just put stuff in there, right? You can compromise the package repository itself, packages, and also the dependencies. All these points, and you can do sessions about all these points on your own. All these points are vulnerable in the software supply chain, and they will be attacked from the outside. And for that, I have some facts that I collected from some statistics. This is from the Sonatype State of the Software Chain report. This is not the actual one. This is from March, I think. And they figured out that over the last 3 years, there was an increase in software supply chain attacks by 742%, which is huge if you think about it. And there's another one from the NIST, the National Vulnerability Database. They also, because they collect all that, they just come up with this chart and told us that in 2021, there have been 20,142 different security vulnerabilities that have been recorded. And you see over the time, it's increasing, right? I don't know why there's this jump in 2017. Maybe people are more aware of security now and report more stuff, but this is the statistics. And one thing that is really shocking is this one. It's user laziness, and that means us most of the times. I talked to Christian Grobmeier. He's one of the maintainers of Log4j. And he told me that I had to make up the numbers because I asked him in March, and in March it was 37% of all downloads from Log4j have still been downloading the vulnerable version, even that it was fixed 15 months before. This is the numbers from now, so it's better now, but still 20% of all the downloads downloading the vulnerable versions of Log4j. This is long time fixed, nearly 2 years now, and still people download the old stuff. It's not actually persons that do that, but probably this is old build scripts, nobody updated that, someone hard-coded a version in there and never really thought about it. Check this stuff. It's shocking to see that, because it's already fixed. But you are still vulnerable if you use this kind of old Log4j versions. And this is just one example, right? The other thing that was also figured out by Sonatype, that 6 out of 7 project vulnerabilities coming from transitive dependencies. So to make it short, you have your application, you drag in some dependencies, some libraries, but these libraries again have dependencies, transitive dependencies, that you don't know. And this could be vulnerable, right? And suddenly your application is vulnerable even if you make sure, oh, I use this version, that should be fine, but you don't know. So this is really a problem, right? And another statistic that I found was from the Synopsys Open Source Software Security and Risk Analysis report. They scanned all their code bases, and they figured out that 84% of all the stuff that they scanned contained at least one vulnerability. And from that, 48% contained high-risk vulnerabilities. It's a lot, right? And I ask you, who's scanning here for security? Cool. How does this work if you do that? I mean, they might not check your code base, but still, you see, everybody says, yeah, we do that. But they have the statistics, and they show you maybe it's not good enough, right? The other thing that they tested is they tested who's using open source. And they figured out 96% of all the code bases used open source, and 76% have been open source itself. And that leads me to open source in general, because who's an open source maintainer here in the audience? This is for you guys. Because this is the license, one license, and you probably know that you don't have to read it. Whoever read this and understand it? Yeah, there are just a few points in there that are really important. It is provided as is, right? And without warranty of any kind. And in no event shall the authors or copyright holders be liable for any claim, damages, or other liabilities. That's what it says. And if you use that, you agree to that. So what does it mean? It means I owe you nothing. That's what it means. So you can't really blame people if they tell you this is what it is, and you say, yep, I'm fine. I didn't read it, but I'm fine with it. And afterwards, you have a vulnerability, and then you blame them, right? You agreed to that. And there's a nice XKCD that exactly shows this problem that we have with open source sometimes. It doesn't mean every open source project is like that, but this could happen. There was something with the NPM module where there was this, what was it, pet left thing that happened a couple of years back where the whole NPM thing broke. This is just a good example on how easy we trust these projects. I just had this. I use it, it's great, it works. You never really think about it, right? So keep in mind that open source maintainers are not suppliers, right? You don't have any business relationship with them. Or did you ever sign a contract with Log4j and pay them? You don't. You just use it, right? So that means if you use the code, it's up to you to make sure that it's secure. It's not up to them. So you have to scan stuff for security, not these maintainers of these libraries, for example. And this is something that people have to think about, right? So this, I try to make people aware of this, because usually you just use it. Because it's great, it works, yeah? I found it on the web. This is now not how it should work. So the question is, what can we do? Right. First of all, there's shift left. Who knows what that is? Probably, not everyone. So if we have the software supply chain here, we see here's the development on the left side, right? And in the former days, in the past, all the ops stuff was on the right side, right? And there was usually where security happened was on the right side. So shift left means we have the development here, we have the ops there, and security awareness should be shift to the left, to us. We should be more aware about security. That's what shift left means in general. And if we take a look at DevOps, then in the meantime it became DevSecOps. And you probably saw this kind of loop with the DevOps loop where you see planning, coding, building, and then releasing. And this is the left side, right? The dev side. And then we have deployment, operating, monitoring, and again, back to planning. So the question is, where's security in this diagram? Is it right? Is it left? It's everywhere. Security applies to all of these topics. That means also to us. Also already in coding and planning. We have to think about that. Not only on the ops side, right? So that means shift left, yes. It's okay. But we also say validate right. And I will explain what I mean with that. So first of all, you have to update your JDK. I already told you. And there are tools for that. Who knows SDK man? First of all, who's using Windows? Okay, this is not for you. Linux and Mac, the rest probably. So for Windows, I think there's Chocolati, which is similar. Oh, maybe. I'm not a Windows user, but if you say so, I trust you. So it supports many JDK distributions. It's command line only. It's for Linux and Mac. You can download and install JDKs. That's the main idea of SDK man, and it can do way more stuff. right? It's not only SDKs and JDKs, it can do libraries, and I don't know. It's huge. Shameless plug, I also wrote my own tool because I was lazy. I hate it when I always have to look up when is the next update available on the website. So I always check, oh, it's not available. Next day, still not available. And at some point you say, well, you don't know. I don't know. I just don't care anymore. So I wrote this tool, and it just checks for all your installed JDK distributions, and then gives you just, it's a taskbar application, and it just gives you a list of the JDKs that it found and tells you if there are updates available. That's the main idea behind this tool. It's written in Java. It's available on all platforms. And it also has information about vulnerabilities, because I applied for the NVD access key, and then I can just ask the NVD for your installed OpenJDK version if there are vulnerabilities, and then they can tell me. So what it looks like is, this is how it looks like on Mac. So you see there's a list of JDKs. It's free, by the way, right? So also the source code. You can just use it if you like. And if not, I'm also fine. So this is just for me being lazy. So you see they have a version installed, for example, Zulu. It tells me there's a new version, and then I can download it directly, and then I have to install it. That's the main idea. And if there's this little red bubble there, you can click on it, and then it will show you all the CVEs that have been found for this specific OpenJDK version. Then you can click on the CVEs and will open it in the browser, and then you can read through the description and stuff like that. The other thing that you can do is static code analysis. Who's doing that? Awesome. That's really good. So it's usually part of code reviews. It identifies vulnerabilities already in source code, and that means at the implementation phase, which makes it very cheap, because you can directly change it. Standalone tools and IDE plugins are available. This is a list that you can find on the NIST.gov site. They also host the NVD. And this is not the list. It's just a list. Right? This is without any, they just said, these are some of this stuff that you can use. You have free versions and versions that you have to pay for, and you can find them there. One example would be Find Security Bugs. That was also mentioned in the keynote. It's free of charge. It's extending spot bugs, and it has more than 400 bug patterns. It's a plugin. And this is how it looks like in, I think this is Eclipse, but this is also available for all IDEs, right? This was just one screenshot that I found. This is okay, you can do that, but there's better things you can do, like vulnerability scanners. Who's using that stuff? Very good. So this is for detecting vulnerabilities. They have databases in the background, and they also know common flaws, so they can test for that. And they can monitor misconfigurations and make sure that you use the latest secure artifacts from reliable sources. They can monitor appearance of new packages with fixed vulnerabilities. So these tools are very powerful. And it can even update your dependencies, and they work on different areas in the software supply chain. They can work here directly at your IDE, for example. They can work and scan on the repository and also on the CI/CD system. They can scan artifact repositories, and they are also available for production. Who's running security tests in production here? That's what I expected. The question is why. So I just assume that you trust the CI/CD system. You test it in CI/CD, it's good, so I deploy it to production. But we know that Java is dynamic, right? Even at runtime, we can drag in other stuff and run code. That's not so uncommon. That means, yes, you can trust the CI/CD system, but you really never know. And why don't people test in production? Mainly because the stuff that is available is agent-based. So it's a Java agent, and I can shortly explain what it is. If we have the JVM as the black box, then it's more like this in the inside. It has different parts, and on the top we see the class loader. And the JVM itself comes with a so-called instrumentation API. Right? That means it has an API, and you can go to that API and talk to the JVM at runtime. And usually you do that with an agent. It's called Java Agent. And what it does, it just adds a callback to specific parts of the JVM. In this case, for example, to the class loading system. And then every time the JVM is loading a class, it triggers the callback in the agent, and then the agent can do something like check this class against some database. You can imagine if that goes on with every class loading, that takes some time, that takes performance, that drags down the performance of your system. And this is one of the reasons why companies don't use it in production, because then they have to pay for the additional performance to get back to the same as they had without the scanner, right? So this is one of the reasons. And this is how it works in principle. Well, there are different scanners available. As you can see, some of them are free, others you have to pay for. And I will just give you 2 examples, like Sneak Code. Is someone using Sneak? Yeah, Brian is happy. Here you can find it. There's a free and paid version. It's 9+ language supported. They have a developer-first approach. Remember, shift left. So this is for us, which is good. And there's a standalone version and also IDE plugin. And they stop at CI/CD integration. The reason is they don't want to go in production, because then you have the agent and it's an overhead and people probably won't use it, right? And it looks like this. So it's not really, you don't have to read it. It tells you where's the problem and what is the problem. This is how it works. And then there's SonarQube. Someone's using SonarQube? Oh yeah, it's big, right? So it's also free and paid. 30+ languages supported. It's more than 4,800 analysis rules. It's also standalone plugin, and they stop at CI/CD. Why? Same reason. I asked them and I said, yeah, you know, in production, we have to use an agent, and that means overhead, and people won't pay for it. So this is, again, the same problem. You don't have to read. It's really just what they do. They tell you where's the problem, what is the problem, and why. So they can, this is just the IDE part, right? They have also, of course, scanners for repositories and all kinds of stuff. Now, shameless plug, we also have one. And the reason why I mentioned that is because this is a different approach. We only run in production. So we are not made for scanning we don't have an IDE plugin or scan your stuff. So it's only in the JVM. So we added it in the JVM. Instead of having something that attached to the JVM, because we do JVMs, we just added it inside. And because the JVM is loading all the classes anyway, and instead of attaching something to the outside, we just made the JVM call a so-called forwarder that is somewhere in your infrastructure from time to time and send them packages telling them, okay, this is the classes that we load. Just check it. And then this forwarder can check against vulnerabilities. And because we can do that at runtime, in production, the overhead is below 1%. So it's really not that big of a problem here. And we have fewer false positives, and I can tell you why. And we also do code inventory. So if you have a huge code base, because we now know all the classes that we loaded, means we also know the classes that we not loaded. So let's say after 6 months, we can tell you, you know what? From all that code that you have in your program, this part you never used in 6 months. Maybe you can get rid of it. Right? So this is also possible with this one. It's no Java agent and therefore also no performance overhead. And we only give you a web interface like this. This is more made for integration. It's like an add-on. We don't see it as a replacement for a security scanner. It's really just as a production scanner. And we can tell you, like all the others, where's the problem, so the libraries, the scoring, but we can tell you if you use it. Right? Remember transitive dependencies. You might have a dependency on a library that drags in the vulnerable log4j version. We can tell you, oh, by the way, there is log4j in a vulnerable version, but you never use it because the JVM never loads the classes, so you're still safe. Right? So this is something that you can't do with an agent. Or it's hard to do, but it takes more performance. So if you would take a look at the secure software supply chain, then it could look like this. So first of all, this is the supply chain. You have third-party libraries like Spring or Log4j, even third-party software. That's interesting. If you go to Kafka Summit, who's using Kafka here? Yeah, but you are Java developers. If you go to Kafka Summit, this is Kafka users. And we had a booth there, and they came to our booth, and they asked, what are you doing? Oh, we do Java. But this is Kafka Summit. I say, yes, and Kafka is running on Java. Really? Oh, we didn't know. Right? So this is sometimes also a problem because these users, they just use it because everybody does, and they have no idea that there's Java involved in Kafka, for example. Code scanners, Sneak, Coverty, Contrast in development, or also CI/CD, of course, also for repository scanning and stuff. Even container scanners are available, like Anchor. And in production, you could use or Azure vulnerability scanner. So if we take a look back, then this is more or less shift left. And we validate that the stuff that is running in CI/CD is also valid for production. That's what we mean with validate right. So the takeaway is you should follow an automated patch schedule. Usually this is the one from January, April, July, October, where we get all the updates from the JDK. And you really should do, because we saw not everybody's on the latest version. You should automate application packaging using JLink. And it's really not that hard. And I will probably do a session about JLink in the future, because it's at same conference, every time at the conference, it's the same result. People don't use it, don't even know it. You should watch out for CVEs and libraries, and you should probably use vulnerability scanners if you don't do already, right? So do you need to be a security expert? No. But you need to be aware about security. That's very important. So, and with this, I say stay secure. And I'm not sure if we have time for questions, because nobody what's 2-3 minutes. So if there is a question, feel free to answer. Yeah, over there.
Which code analysis did you consider SAMGraph?
The examples that I gave were with code analysis, you mean? No, I just gave you a list, right? There's tons of tools that you can use. This is just the list that I found from the website, from the NIST.gov. But there are so many different security tools. And like I said, I'm just a developer. I'm not a security expert. This is just the stuff that I figured out, and I thought it might be useful to share with others. Because for me, it was quite insightful to see what's available and what are the CVEs that are attacking the OpenJDK project. And so we really should do something from our side. Any other question? Yes?
Do I understand it correctly that Azure has its own GRE?
We have our own JVM, yes. Yeah, but it's a build of OpenJDK. But this is a different story, because this is also something that people need some education. And if you take the source code from OpenJDK, you can add stuff to it. That's what we did, without breaking the TCK. So it's still totally compatible to everything else. We just added something that calls outside the JVM.
Then wouldn't you then still need to run it in development and test as well, to make sure that you have the same?
You can, but you don't have to. It's not really needed. Because it's not really that this JVM is different in the code that it produces. It's based on OpenJDK. So you can use, for example, Oracle JDK or Xamarin in development. In production, you can use Azure, and you will have the same results because it's the same compiler. There's no difference there, right? We just added this call outside of the JVM. That's more or less all. But there was another question? Create your own ones.
Sorry?
Create your own ones.
Yes.
No, not really. This is the problem. People just go to Docker Hub and just use some base image. Sometimes they never really check where it's coming from. They just use it. Oh yeah, there's a base image with whatever inside. Like I said, it doesn't take a lot to create your own images using JLink. It's way smaller, and if you integrate it in your CI/CD process, then this is not a big deal. You just need to create a Docker script to do that. So I would suggest not using base images. Just create your own, really for your application, tailored to your use case. It's smaller, makes the deployment easier, and you don't need that big memory footprint. Because if you have to think about a base image it should solve a lot of problems. So that means usually it's a JRE inside. 150 modules, 150 megabytes. But you don't need it, right? And you open the doors with security vulnerabilities for attacks for stuff that you don't even use, right? But it's in the JDK means, or in the JRE, it is attackable. Okay, I think we run out of time. Yeah. Okay, that's it. Thanks for attending.